So we have quite a packed day today, with quite a lot of well, presentations and talks and introductions to basically the OpenZFS community in Europe. I'm really happy and really proud to say we've got Matt here from, well, the co-founder of OpenZFS. Yeah, he's down here. He's going to do a lovely presentation for us about OpenZFS and a little bit about the Lumos, what's going on in Lumos, followed by Andre about doing a talk about FreeBSD, and as well as Luke Marsden from Hybrid Cluster doing a little bit about Linux, and then we'll go for coffee. So without kind of further ado, I'm just making sure I'm well in view of the camera. It's a good thing I'm not seeing the live stream, it's fine. I'd like to just hand over to Matt, and yeah, so we can start the day and get cracking. Matt.
Yeah. Thanks. Can you hear me? Okay. And one other announcement I wanted to make is that there's going to be several opportunities for you all to participate in talks this afternoon. And for people who would like to participate, I have some great OpenZFS t-shirts, an earlier version of which is modeled here. Yeah. You can get it in this nice light blue color. Cool. So I'm MattAhrens. I helped to create the ZFS project back at Sun Microsystems in 2001, and also create the OpenZFS project more recently. I work at Delphix. I'll be talking some more about what we do at Delphix later on today. So this talk is just about OpenZFS. So I think probably most of you know this, so I'll fast forward a little bit through the recap of what is ZFS and why should you care. As you guys probably know, pooled storage, so you can create, take a bunch of disks, put them into a pool, create a bunch of file systems out of that. You don't have to worry about statically assigning disks or partitions to individual file systems. File systems can just grow and shrink using space from the pool as they need it. What else do I want to mention here? I think you guys are familiar with this. So one thing that I like to say is that when we created ZFS, one of the main goals was to end the suffering of system administrators. We saw how hard it was for people to administer separate file systems, volume managers, and storage products. So we wanted to create a unified interface and make that interface easy to use. So with things like delegated administration, where you can partition, partition isn't really the right word, but you can delegate the ability to administer your storage pool to, for example, individual users or to owners of particular containers or zones within your operating system. Right. Another thing that I think really feeds into ease of administration is actually a lot of the things that you don't think about in terms of administrative model, but by removing limitations that existed in previous storage products, like number of files in a directory that you can have, amount of total storage, number of disks, things like that, we make it easier for the system administrator to design a system that works for them, rather than having to design a system, architect a system that works around your file system's limitations. Cool. So this shows kind of how ZFS fits into the overall software stack. So on the left, we have an example of an old school software stack with a separate file system and volume manager. A lot of information gets lost along this interface between the file system and volume manager because it's just a simple block interface. Versus in ZFS, we've re-architected the insides of the software stack for storage, and we've separated out into kind of three main layers. The upper layer deals with the POSIX semantics for files, like files, owners, permissions, things like that, and also virtual volumes. And then this middle layer deals with just providing atomic transactions on objects. So you can, for example, the POSIX layer, if we need to rename a file, we need to remove the entry from the old directory, add the entry to the new directory, and maybe change some information about the file itself. So this layer only needs to worry about the things that it needs to know about. So for example, it knows, here's the file, here's what I need to change about it. It doesn't need to worry about how that gets implemented. The layer below takes care of all that atomicity. And then the interface between the DMU and the SPA, this is kind of most analogous to the interface between a file system and a volume manager, but you see that it's actually very different because in the traditional model, the file system chooses where to write something. It needs to worry about allocating space, all that kind of stuff. And the volume manager worries about, well, it doesn't worry about as many things as it should, but it worries about writing it to two places, for example, if it's mirrored. In ZFS, the DMU, it just knows, okay, I have this chunk of data that I need to get written to disk, and then I need to get it back at some point later on. The SPA worries about everything to do with how that data is stored. So it takes that data, it might compress it, then it's going to actually find space on disk to allocate for that. It might need to allocate a little bit extra space if you're using RAID Z. It needs to allocate some extra space for the parity information. And then it writes it to maybe 2 disks if you're doing mirroring, or a bunch of disks if you're doing RAID Z, and then tells the upper layer, okay, here's the token that you can use to get the data back when you need it. By the way, any questions at any time here, just raise your hand or shout out. We're going to be getting into a little bit more of the philosophy of ZFS now, so any technical questions or just things you want to talk about, just let me know. So a little bit of the history of ZFS. How did we get to this point here where we're having this conference? Back in 2001, it was just me and one other engineer, Jeff Bonwick, who started working on ZFS at Sun Microsystems. As I mentioned, we saw all the problems with existing file systems and how hard it was to for people to use them. We weren't actually, we weren't industry vets of the storage system. We were mainly outsiders, seeing how hard it was for people to use existing storage solutions, and we wanted to come up with something that was better. So in 2005, and by the way, there were a ton of people working on this, not just 2 guys. There's like, within a year, we had over a dozen software engineers working on ZFS at Sun. We released the source code as part of the Open Solaris project in 2005. That enabled ZFS to be ported to a lot of different operating systems, starting with FreeBSD, where it was released in 2008 as part of FreeBSD 7. But then there's this kind of big event that was a little bit disconcerting in the industry. As a whole, but also more specifically to people who are fans of ZFS. So Oracle acquired Sun Microsystems and basically stopped contributing. It basically killed the Open Solaris project and stops contributing any source code to ZFS. So the reason this is such a big problem is because up until this point in time, ZFS was open source, but the vast majority of all source code contributions came from Sun. And all the all changes needed to go through Sun. Basically, they were the the gateway and the arbiter of what was ZFS, and perhaps rightfully so, given that they were contributing the vast majority of the work to ZFS. But given that that contribution was going to stop, that's very there's really a question of like, was ZFS just going to die and become this proprietary technology only and be forgotten in the open source world? So thankfully, some people got together who were creating products based on Open Solaris and formed the Illumos community. Illumos is basically a continuation of the Open Solaris project, but under a truly open development model, meaning that there's contributions from many different companies. There's not just one company that's controlling all the changes. Cool. More recently, we've seen ZFS ship as part of, we've seen the ZFS on Linux port become really much more mature. This is an in-kernel implementation as a Linux kernel module, and we have a few people here today who have created products based on Linux. I'll be mentioning them a little bit later. So then, just in the past year, we saw that there were all these different ports of ZFS. So Illumos, Linux, FreeBSD, and they're all kind of doing great on their own. But we saw that there's starting to be a lot of duplicated effort between the different platforms. So we created the OpenZFS community as a way to try and unite these different platforms, and I'll talk some more about the specific things that we did later. There's also a new member of the OpenZFS family, which is the ZFS for macOS 10 port, which is much less mature than some of the other ports, but gaining a lot of momentum, and it's really cool to see a new platform join the OpenZFS community. Any questions about history and kind of how we got here?
Kind of.
Yeah.
What is, I mean, it's kind of tied into this, what is the licensing situation with OpenZFS? And is there one?
So OpenZFS is licensed under the CDDL, which is the license that Sun created to release the source code as part of Open Solaris. That's still the case. Is that?
What are the implications of this? So what are the implications for this license? I understand this maybe some complexities with using ZFS. I mean, this license is kind of a bit unknown to everybody. It's kind of like, oh, what's this? I think it's one of the problems that the community faces is effectively explaining what the implications are. I mean, I hear a lot from people like, oh, it's not really open source. What
Sure.
is it? What is it? What's
So
the
so I'm not a lawyer, so this is not like a legally binding anything, but my understanding of the license terms of the CDDL are that if you make changes to specific source files that you received under that license, and then you ship binaries that are a result of those changes, then you need to release the changes to those particular source files. So you can think of it as kind of somewhere between the GPL and the BSD licenses. So kind of like the GPL, you need to contribute changes that you make, but it's more explicitly defined as being on a per file basis. So you can take, so for example, like the port to FreeBSD, FreeBSD is generally under the BSD license. So they have separate files for things that are BSD licensed and separate files for things that are CDDL licensed. And then when they make those changes to the like the ZFS code, which is CDDL licensed, they release that under the CDDL license as well.
So it's not something to be scared of then, I see.
Yeah, I mean, I don't think that it's anything to be scared of. It's an open source, an OSI certified open source license. So I don't think that there should really be any question about whether it's open source. Like it has the open source stamp of approval from the people who give that stamp. So and I think it's I would say that it's more open than the GPL because it's clearly allows you to make proprietary extensions in separate source files, and a little bit less open than the GPL license in that it does require you to share changes to those source files.
Thanks very much.
Cool. Yes.
Do you want the microphone?
Thank you. Hi, I guess Oracle are no longer contributing to the OpenZFS project, but can you say anything about Oracle's acquisition of Greenbytes this week and what that means to, what they've acquired is going back into their ZFS product?
Unfortunately, I can't really. I don't know anything about that more than what I've read in the news, which I'm sure you have.
All right, thank you.
Yeah, sorry. Any other questions? Cool. So, all right. So I mentioned OpenZFS. So what is OpenZFS? What is the point of it? So as I mentioned, it's a community project. The point is to bring together open source developers from all the platforms that are building on top of OpenZFS. So we want to make sure that people are aware of the fact that open source ZFS is alive and well. ZFS is not just a proprietary technology that belongs to one company. It's open source software that belongs to all of us. We want to make sure that people, developers in these different communities are talking to one another, and that they aren't duplicating work that's happening on Linux as well on FreeBSD. We tend to come from these specific communities where we're used to doing things a certain way on a certain operating system. We have our own development model, and from talking to people who are working on these different ports, I realized that they're facing a lot of similar problems. For example, in Linux and on FreeBSD. So I wanted to bring together those developers so that they could, have discussions about these bigger issues together. And lastly, we wanted to ensure that the experience of people using ZFS is the same or comparable on all the different platforms. So as part of creating the ports to from Lumos to FreeBSD and Linux and Mac OS X, we kind of accidentally forked the source code by necessity, but we wanted to make sure that it's easy for people to share source code from one platform to another, so that those forks diverge as little as possible. So what do we do to towards those goals? So like any good open source project, the first thing that we did was create a website with a wiki and a mailing list. In this case, the point of the mailing list is mainly for developer discussion. So this isn't intended as a replacement for the platform-specific mailing lists where people can ask about like, how does ZFS, how do I use ZFS on this platform? I ran into a little problem. Can you help me out? This is more for developers to talk about the source code changes and the issues facing the developer community. Come on in. No problem. I'm going to skip over a few of these points we'll get to later. So I'll talk in some more detail about some of these, but I wanted to call it the office hours. So we have office hours about every quarter. This is an online event where an expert in the community, like a ZFS developer, hosts kind of like a call-in Q&A where people can call in via YouTube and video chat and IRC to ask about what's new in ZFS, what are you working on? I ran into this problem. Can I get some one-on-one help? So this has been pretty popular, and I think it's time to schedule another one because it's been a couple months. So I'll probably be bugging some of you to see if I can get some more participants. So how do I start? So all these ports, all these different platforms are really very, very active. These numbers are a little bit out of date, but you can see that there's about 100 people contributing source code changes across all these platforms. The newer, the less mature ports you see have many more commits as they're just starting or in the middle of the porting process. And the stability of ZFS on these different platforms has enabled a lot of companies to create products based on OpenZFS. And we have people from several of these companies here today. I wanted to ask, maybe for a show of hands, how many people are using ZFS on Illumos? Oh, cool. About maybe a third. How many people are using ZFS on FreeBSD? Another third. Cool. How many people are using ZFS on Linux? Wow, this is amazing. It's like almost exactly split into thirds. I think this is probably the first event where that's been the case. Oh, and I wanted to, is anyone using ZFS on OSV? Okay. Claudius Systems has created a new operating system called OSV, and it's designed specifically for use in cloud virtualized environments. So it only runs on hypervisors, and it actually has no userland components. It basically, they observe that there's in modern cloud deployments, there's a lot of different layers. So basically, you have like an application that's running on an operating system, and there's usually only one application running there. And then the operating system is running on a hypervisor, and then the hypervisor is actually running on the bare metal. So basically, they removed a bunch of those layers in the operating system and higher to create like a very thin kind of container around applications. And they wrote this operating system totally from scratch, which is kind of amazing. And one of the few components that they took from the open source community was the file system, which is ZFS. So I'm really curious to see where that project goes. So that's why I was just curious if anyone here had used it. But there's a lot of companies that have created products based on OpenZFS on Illumos, Linux, and FreeBSD. Many of them here today, and this includes companies that are creating kind of traditional storage products, like Nixenta and IX Systems with their FreeNAS and TrueNAS systems, as well as companies that are creating that just need storage as part of their product, not as kind of the main thing that they're selling. And we're going to hear from some more vendors, I think, in the next sessions. Any questions about vendors, platforms? Okay, cool. How are we doing on time? Okay. So, yeah.
Just one quick question. How do you think we can arrive on the Illumos community to the number of committers the Linux one has?
Yeah.
Like 52 contributors on Linux? Less than half?
Yeah. So I think that's a good question. Oh yeah, sorry. I'll repeat the question for the people on the video. He was asking, basically, how can we increase the number of contributors on Illumos to get to the level where they're at on Linux, for example. I think that would be great. I'm not sure that that's necessarily a requirement for success on a given platform. I mean, you look, there's even fewer contributors on FreeBSD, but we saw that there's about a third of the audience is creating products based on FreeBSD, even given so few number of contributors. So I think there is a power that a relatively small number of people can make a big impact on on ZFS on a given platform. And I think that these numbers are kind of show the diversity, but they don't show the depth, right? So, I mean, to my mind, 24, like if you have 24 people that are actually working, or let's say, even 19 people working full time on ZFS contributions, I mean, that's huge. That's going to be, be a lot of work to make that platform ZFS support really great, and hopefully contributions that we can use on other platforms as well. That said, I think it would be great to attract more people to the Illumos platform, but I think that that is primarily a Illumos platform issue and not so much specifically a ZFS issue. I think that OpenZFS is going to be a success because of because of what OpenZFS offers, and because it's available on the platforms that people want to run it on, right? So, maybe someday someone will dethrone Linux, and Linux won't be the #1 server operating system in the world. I think that is not necessarily a good or bad thing, and I hope that file system technologies like OpenZFS will be able to find a home on whatever platform people want to be able to use it on. I know that's kind of like a non-answer to your question, in that I don't have any specific suggestions for how to increase contributions on Illumos, and I'm sorry for that, but hopefully we'll be able to be successful despite that.
Do you know when we can expect to see version 1 of Linux, of ZFS on Linux?
That's a good question. The question was, when are we going to see version 1.0 of ZFS on Linux? Do you have any more insight into this?
So 0.6.3 is coming out really soon, and that looks set to be a really good release.
Yeah, I definitely. I mean, I agree with where you're coming from in terms of having. You want to be using a product or software that someone stands behind enough to at least say that like, hey, this is 1.0. 1.0 is a good start. Most people don't even want to use a 1.0 product, right? So I think that's there's a lot of people with that sentiment, and I think that the people who are kind of in charge of the ZFS on Linux port from Lawrence Livermore National Labs in America, they definitely have a pretty thorough engineering culture. So I think that they don't want to market 1.0 until it's really something that there are no known issues with, or at least no critical issues with. And I think that that conservatism may be a little bit at odds with the overall Linux development mindset. So mainly what I can say in terms of the Linux stability is that there's a lot of people here today who are using ZFS on Linux in production, and we're going to hear some more about their specific use cases later today. But I would also love to see a 1.0 release.
I'm just thinking from what I understand from ZFS on Linux, it's entirely from a Lustre context. So everything that's developed pretty much everything that's developed for ZFS on Linux, it's by Brian Beerlendorf at Lawrence Livermore, and it's just for Lustre. That's what he's being paid to do, is to support Lustre. So I think it's like, when's the other nice bit's going to happen?
Yeah, so I would actually disagree with that a little bit. Just I guess to repeat the, well,
I was going to say, and do you want to say that again with the mic?
Yeah.
okay.
So my impression is that ZFS on Linux after testing it quite a lot and also setting up Lustre with it as well, is that it works really, really well for Lustre, and it seems to be being developed, of course, by Brian Beerlendorf at Lawrence Livermore for their Roadrunner cluster for Lustre. And so the 1.0 question was kind of more like, when's the rest of it going to be finished? I mean, for instance, the NFS support's kind of shabby, and there's some bits missing here and there, and yeah, you disagreed though, I think.
Yeah, so I guess the part that I would disagree with is that is just that Brian and the guys at Lawrence Livermore are only tasked with the supporting Lustre. My understanding at least is that they've actually been given some pretty broad independence to make ZFS on Linux be great for everyone. So they definitely started with just the Lustre support, and there wasn't even any ZPL, so you couldn't actually use it as a real file system. But they were actually, given the success of that, they were given the responsibility to actually go and make this a real thing in the community and finish the ZPL port. So I think a lot of the stuff that they're working on nowadays is actually more towards the community and making ZFS work well for the community at large.
Yeah, cool. So yeah, 6.3 really will be an interesting release then when ZPL comes out and stuff. Yeah, okay, cool.
Did you? Okay, I thought you were raising your hand. Okay, cool.
Thanks.
Where are we? Okay, cool. I think I'm going to fast forward over some of this specific things, unless people have questions about it, and I'm going to get to some more general points about the OpenZFS community and the code base. So there's a bunch of things that we developed that I'll mention just recently. One of the first things that we realized that we needed as part of the OpenZFS project was the ability to independently develop changes to the on-disk format at different companies, and then integrate those changes, those features together into a common code base. So we developed feature flags, which enables that. So this is alternative to the linear version number from Sun Microsystems, which worked fine when there's just like kind of one central authority on what is ZFS. Here it enables like a multilateral development of on-disk feature changes from different companies. This is some performance improvement stuff that I worked on recently. This is actually not intended to be strictly a performance overall throughput improvement, but a way to improve the to make sure that you get consistent performance. So ensuring that latency is roughly the same from operation to operation, rather than having these huge outliers that we saw with previous releases of ZFS. So we went from outliers being multiple seconds to only 30 milliseconds. So the outliers here means basically that 99.99% of all the operations took less than this amount of time. Any questions about this stuff? Cool. And if you'd like some more info on this, my colleague wrote up a couple of blog posts explaining it. Also in OpenZFS, we have LZ4 compression. The really cool thing about this is it's faster and better than the previous default of LZJB. It compresses and decompresses using less CPU, and it actually gets to, a little bit better compression ratio. The thing that's really cool is that because it uses so little CPU, and it's able to reject things that are uncompressible very quickly, you can almost always just enable compression with LZ4 and actually get better performance on almost all workloads, because by compressing the data, there's less data to read and write to the disk. Cool. I'm going to skip over this. All right, cool. So I mentioned earlier that one of the goals with OpenZFS is to enable us to share code changes from one platform to another more easily. One of the ways that we're going to do this is by creating a platform-independent code repository. So let me go to the diagram for a second. All right, so currently the kind of status quo is that there's lots of changes to ZFS being made on all these platforms, but the changes are only really being pulled in one direction. So when we make a change in Illumos, it's pulled down into FreeBSD and Linux, and then from Linux to macOS 10. But if somebody makes an enhancement in macOS 10 that really could apply to all the other platforms, there's no common mechanism to get those changes into the other platforms. Part of the reason for this is that everyone only wants to work on their own platform, which is totally understandable, right? Like it's really hard to figure out how to upstream stuff when you have to get a new operating system, figure out the development model, get a development environment, figure out how to compile it, figure out what mailing lists to talk to. If somebody, like as I said, if we make an enhancement in FreeBSD that fixes part of the generic ZFS code, it's really rare that we get that picked up in the other operating systems. So the goal is to create a platform-independent code repository, the OpenZFS repo, and all of the operating systems will be able to pull changes from that and also push changes to it much more easily than they can upstream changes today. So how are we going to make that actually easier? So the goal is that we'll be able to actually test all the code in the OpenZFS repo in userland. So that means that if you're developing changes for the Linux kernel, you'll be able to test them out in your Linux kernel module, and then also apply those changes to the OpenZFS repo, compile that code as a userland library, and test it out in userland on your Linux system. Once you're sure that it works on Linux, then you can upstream those changes into the OpenZFS repo without having to have any other operating systems involved. So by sandboxing the code that runs in that environment, we'll be able to make sure that it uses only defined APIs that exist on all the other operating systems, thereby ensuring that you can test it on one platform and be sure, or at least reasonably confident, that that code is going to work on all the other platforms as well. Cool. So this is going to include, as I mentioned, the code that is actually platform independent, which is most of ZFS, but it doesn't include, at least initially, it's not going to include the ZPL, which is the POSIX layer. So there won't be any the intent is not that you would use this code in the OpenZFS repo directly for anything other than testing, but rather that it would be easy to pull that code into the kernel implementations on the different platforms. Questions about this? Yeah.
Hey, so when you're testing the sort of userland version, I was just wondering whether if it's running in userland, can you actually interact with it as a file system in userland, or?
So no, so there isn't like any fuse support or anything like that. So there won't be any way to interact with it like by like creating and removing files. So today, this userland implementation does kind of exist in the form of libzpool, which is used by like ztest, which is a test program, and also zdb, which is the debugger. So this is already true to some degree, but we're working on creating a mechanism so that you can use the ZFS and zpool command line tools to interface with the libzpool userland implementation as well. So this will enable us to test a lot more of the code in userland, because actually, I think more than 25% of the ZFS source code is actually in the userland libraries like libzfs and the ZFS command line tool. So that will enable us to basically port the test runner test suite to run against this userland implementation, which will give us much broader test coverage.
Cool.
And part of that is going to be creating some little shims that will allow you to do things like read an object, write an object, create an object, things like that. But it won't really be like a file system. It won't look like a normal file system.
What do you mean by Illumos will get the also non-gross porting layer?
Yeah, so I think I have another slide here. No, I don't have a slide on that. Okay, in the set. So the idea is that I mentioned this sandbox that we'll put the code in. Basically, that means that all of the interfaces that the ZFS code uses will be pretty strictly defined by like porting layer, or I've been kind of tentatively calling it like the ZKI for ZFS kernel interfaces. So like rather than calling like mutex enter or nanosleep or things like that directly, we would create like wrappers for that, like ZKI underscore mutex enter, and then ZFS would call those routines. So every platform, including Illumos, would have like a small shim layer that translates those ZKI routines to whatever the native platform does. And then part of the OpenZFS repo would be a userland implementation of those ZKI routines that uses just like the POSIX interfaces, like POSIX mutexes and things like that. Yeah.
We talked before about FreeBSD and zvols. Which is a horrible if-def at the moment. Is your goal that that would also be abstracted out?
We're not really trying to attack that with this specific, with the OpenZFS repo. Because that is platform specific, really for this, we're just trying to attack, the lowest hanging fruit, which is the code that really is platform independent, like the SPA, the DMU, the DSL, most of the libzfs stuff, the ZAP, the ARC, all those things that are not at the periphery. So basically everything except for the ZPL and the ZVol code, and then like the VDEV disk. So basically the very top layer and very very bottom layer of ZFS. Yeah. So sorry, that really is like the way that the ZVol works necessarily needs to be different on each platform. So the best story that I have there is that as part of porting the test runner test suite to run against the userland implementations, it should be fairly straightforward to extend that to also run against the kernel implementation, which will hopefully make it much easier for people doing, like, for example, FreeBSD development to run a full test suite against their kernel implementation, including the zvol support, to catch problems like the one that you saw, earlier in the development cycle. Cool. So we're reaching the end of the talk. I will mention a few things about how to get involved, and then take questions about kind of open projects that we're working on. So I think most of you guys probably already know this. You are involved in the community. But if you're making a product with ZFS, then get in touch with us. Let us know. We'd love to put your logo on our website with a description of what your product is and how ZFS helps to make it successful. And also on the back of the T-shirts that we print up. Most of these, I apologize for some of you if your logos aren't on there. These T-shirts were actually made for a FreeBSD specific conference that I was at last week. So it's mainly FreeBSD companies on the back of it, which is not intended to be representative of all of the companies using ZFS. So if you're using ZFS as an admin or a user, let people know. Help us spread the word about the technology that you're using. There's a lot of people who I've talked to who say to me, "Hey, like, oh, ZFS is still around. Like, I used it, 7 years ago when it was part of Solaris, but Solaris seems kind of, well, I won't mention this on the video stream, but they aren't using Solaris anymore, and they didn't know that ZFS is available on the favorite platforms that they're using now." So I think we definitely have some evangelism to do, and this is mainly I think you guys probably already know this and you're doing this, but this is something that we need to be better about sharing with the rest of the community and getting the word out. If you're writing code, if you're working on with the ZFS source code, please join the mailing list, and get help with your projects, get advice on your source code changes, and this week we're announcing the second annual OpenZFS Developer Summit. This is going to be a 2-day conference in November 10th and 11th this year in San Francisco. The conference last year was really successful. You can see on the OpenZFS webpage there's video recordings and slides from all the presentations last year. So we're hoping to have a similar conference. It's probably going to be a little bit bigger. We're not sure if it'll actually fit in the Delphix office in San Francisco, but we're hoping we'll be able to squeeze in. We're going to do the talks a little bit differently this year. So last year was a little bit of an unconference style, where we kind of flew by the seat of our pants a little bit. So this year we're asking people to submit talk proposals. The deadline for that is in early September. And we'd love to hear from you guys. I know it's a long ways to go from Europe to San Francisco. I just made that trip, so I definitely sympathize with not wanting to deal with the jet lag. But it would be great to see some of you there if you can make it. And we'd especially love to hear about how you are using ZFS or enhancements that you've made to ZFS. And so please submit your talk proposals. Cool. So last thing that I have is a list of projects that we have either recently implemented or are working on. And I'm not going to go through these one by one. I'll just take any questions about specific things or just anything in general. Questions for me? Yes.
Yeah, so I was interested to know what's the status on resumable send receive.
Yeah, we've been working on that for quite a while. This is actually a project that was started by a new hire at Delphix, I want to say like 2 years ago. And we've kept putting it off and putting it off and putting it off. And finally, it is actually on the roadmap for our the next release of the Delphix product. So it does actually have to get done. We plan to finish this by the end of the calendar year. Yeah.
One of the things that I'm a bit confused about at the moment is this interesting fragmentation problem with ZFS. And it's kind of like one of the things that everybody's a bit confused about. Can you clarify what the issue is and sort of what's being done to fix it and mitigate it and so on and so forth?
Yeah, so the issue is especially when a storage pool gets fairly full, then the free space can become very fragmented. So essentially, when we write data, with ZFS, it's copy on write, meaning that we can write wherever we want, but we can only write to where there's free space, not just literally anywhere we want, overwriting your existing data. So ideally, we're going to have a big chunk of free space, and we're going to take all of your writes. They might be to random logical locations. We can take all those writes and write them out nice in one contiguous chunk on disk. So that's going to get really, really good write performance. But if the free space gets very fragmented, so that it's just like little bits and pieces of free space throughout the whole storage pool, then when we're writing data, we have to just write to all those little bits and pieces. So if you're using a disk, it has to actually move the disk head all over the place. So it's much slower, up to like 100 times slower to do random writes versus sequential writes. What's being done to address this? We run into this problem a lot at Delphix because we host databases which use small block sizes, which tends to exacerbate this problem because the little bits and pieces tend to be even littler. So we've attacked this in a number of different ways. We saw that there were actually some problems with the space allocator where we were not finding big contiguous chunks and using them when we should have been. I think I mentioned somewhere on this slide it says something about it. Anyways, we added some more tracking information on disk that tells us essentially a histogram of the chunk sizes of free space. So essentially it lets us tell, like, on this part of the disk, I might have a megabyte free, and on this part of the disk, I might also have a megabyte free. But I can tell that in this part of the disk, that megabyte is all in 1 kilobyte chunks. It's like 1,000 1 kilobyte chunks versus on this part of the disk, it's actually 2 512K chunks. So it's much preferable that I use this part of the disk, even though it's the same amount of free space in both of them. It's more contiguous over here, so I want to use that. Another thing that we're working on right now is, so in part of that work is the fragmentation metric. So when you do like zpool list-v, it actually shows you how fragmented each device is. So that at least can help you understand, like, I'm seeing bad performance. Is it because of fragmentation or is it because of something else? Another thing that we're working on right now is the ability to preserve some of that those chunks of contiguous free space. So we look at how busy the system is essentially, and when there aren't a lot of writes going on in the system, we'll actually proactively seek out those little bits of free space and fill in those holes. So this makes those writes slower, but it preserves those chunks of contiguous free space for when you actually need them, when there's a high write throughput workload. By doing this, we've been benchmarking it with a test that's pretty tough. It just we like allocate one big file that's like 75% the size of the storage pool, and then write to random offsets within that file with like an 8K record size. And we've seen improvements of several percentage points on the fragmentation metric, which is pretty good when under like kind of a varying workload where it's like fast and then slow and then fast and then slow. So I don't think that any one of these things is a panacea. Like, there is a fundamental problem here of needing to write to these random locations, but we're kind of doing the best that we can to make sure that we aren't making you pay that price when you don't absolutely have to.
Is a disk defragmentation thing on the way, or is that even possible?
I don't know that anyone's working on disk defragmentation. I think that while it might be theoretically possible, I don't think that that's actually a practical solution because there's going to be a lot of cases. Disk defragmentation, essentially, it's probably really slow. And because of that, it's probably not practical to run like in the general case. We were pretty reluctant to even do this algorithm of like when there's not a lot of load, then fill the holes, because there's so many workloads where you're under basically constant load, and we know that we need to perform in those. We need to perform well in those cases as well. So I think that the performance implications of doing that defrag would be so extreme that it's like, you can't start a defrag and then like wait, a week. If it takes a week to do it, then by the time the week is up, you will have created more fragmentation during that time.
No, I was meaning more something like a process that's just like a light process that's going. Well, you should probably be over there, and just something a gentle. not a Windows style, like sit there for 9 hours and wait for things to come back online.
I have a question.
Yeah.
I have a question about device removal. So,
yeah.
what do you think about it? Why do you think, first, why it's such a compelling feature? And secondly, how would you go about it? What's the plan on doing that? Because I'm not sure that's your intention to implement block pointer rewriter.
Yeah. I'm definitely not tending to re-implement the mythical BP rewrite feature, which is kind of related to like the defrag, where the performance implications are really, really kind of extreme. So the use cases of device removal, there's kind of two main use cases that I'm thinking of. One is basically people who make mistakes. So if you accidentally add a device to the storage pool, there's no way to undo that right now. So if you meant to like add a device as like maybe you meant to do zpool add pool name log device name, and instead you forgot to say log, then you just add that device to your main pool, and there's no way to remove it. So everyone makes those kind of mistakes. So being able to correct those kind of small mistakes is one use case. Another use case that we've seen at Delphix is because our users don't make mistakes, so they don't have that problem. But in all seriousness, we've also I'll talk a little bit more about our particular use case of how people use Delphix in the next session, but I guess briefly, they're using Delphix. They're using Delphix and OpenZFS as like a virtualization layer, and depending on their workload, they might need a lot of storage for like this for a given project. And then when they're done with that project, they don't need that storage anymore. So they want to be able to remove that space from ZFS. So having that flexibility. That's kind of the other main use case. So this is not like, because it's virtualization, they aren't like literally going and like pulling out drives from one machine. It's like, we're running on top of like LUNs on a SAN or something. So it's pretty easy for them to do that in general, but they can't do it with ZFS because they can't remove the devices.
And so how are you going to go about implementing that?
So the way that we're going to implement it, to contrast with the BP rewrite mechanism, the BP rewrite idea was that you could like take any block pointer and move that data somewhere else and find all the block pointers that point to it and change them to the new location. So the great thing about that is that when you finish this process, the pool is basically in exactly the same kind of format as it was originally. So there's once you finish the process, there's no additional performance cost because all the block pointers just point directly to where the data is. The bad thing about that is that process can take a really, really, really long time. Imagine performance of Scrub combined with the performance of dedupe, like times 10. The way that, not great. So the way that we're going to go about implementing this device removal is using something that we call an indirect VDEV. So the idea is that we're going to take all the space that's allocated on that device that we're removing, and you can think of it as like allocate a big file that represents that device and then copy the space into that file. So essentially we're adding another level of indirection in terms of, when we look up a given offset in that file, the file maps to a given location on disk. So it's actually a little bit trickier than that, not like using a literal file, but using like a mapping that we'll store in the SPA layer. And the reason that it needs to be a little bit trickier is because we want to make it so that at least for file systems, when you read that block, we'll have to go through this additional translation to find, it's on this indirect VDEV, but that part of the indirect VDEV is actually stored on this real concrete VDEV. Once we've made that mapping, then we can actually tell the file system, oh, here's where it actually is on disk. So you can replace that block pointer in that one file system. So the next time you read it, we'll be able to go directly to the location on disk. And then we can like proactively make those translations, on if that's needed.
Okay, thanks.
Cool. Any more questions? Yes. What about encryption? So a lot of people ask about encryption. I've actually, I think, at every event I've been to, at least 2 people ask me about encryption. But as far as I know, nobody is working on it. So there's a lot of different kind of ways to implement encryption. Obviously, it depends a lot on what your, what the use case is, what attack you're trying to prevent against. So there's products that work like below the level of ZFS by doing like encrypting the whole disk. There's products that work above it by encrypting individual files. I think that it would be really much more convenient to have it be implemented inside ZFS. But like I said, as far as I know, nobody's actually working on this. I think that the way that Oracle implemented ZFS encryption is probably overkill for the vast majority of use cases. I think a common use case, well, probably the most common use case is I need to check this box on something that I'm, on the product that I'm selling to my customers, and for that, any kind of encryption works. But another, compelling use case is like I have this. I want to make sure that I just care that all my data is encrypted at rest, so that if somebody walks into the data center and pulls out a drive, then they don't have anything valuable. So for that, like whole pool encryption would be much simpler to implement than the like per data set key management stuff that's in Oracle ZFS. And I'd be happy to work with anybody that's interested in implementing that. We don't have any need for it right now at Delphix, so we aren't going to be working on it in the foreseeable future. But I'd be happy to work with anyone who does need it.
There's even a simpler use case. My laptop.
Yeah.
If it gets stolen.
If it gets stolen, you don't want anyone to have the data. Yeah. Yeah.
It's not using ZFS because of this. It would.
Cool. Yeah, that's good to know. Yeah, if anyone works for a 3-letter government agency and uses ZFS, yeah, get in touch. Or don't. Either way. Did I see another hand up for the? Yeah. Yeah, so the embedded block data, the idea is it's actually a little bit more generic than that, which is that any, so like in ZFS, we can compress data. And we take any block size and we can compress it down and then we store it in a smaller block. Well, the smallest block that we can store it in is like just one sector of the disk, so like 512 bytes or 4K. This is targeting things that are very, very compressible that can actually compress down into about 100 bytes or less, and we actually take that data and put it into the block pointer itself. So rather than the block pointer like pointing to the compressed data, it actually just contains the compressed data directly. So this saves space, not so much space on 512 byte because it's only like 100 versus 500, but it saves a lot of IOs because you don't have to do the IO to read and write that data, and it helps with fragmentation because you don't have all these tiny little blocks. So yeah, if you have a small file, the block pointer, the D node has a block pointer inside of it. Normally that points to a block. But if the file is very compressible, then we'll just store the data in the D node directly. This is especially good for like directories because most directories only have a few entries in them, and so they're just using like one 512 byte sector to store all those entries. All the entries are really, really compressible because they're just like text. So most directories actually can be compressed away. They don't actually use any blocks because of this. There's also a bunch of data structures that we use internally for other types of metadata that often can take advantage of this.
Does that mean that the checksum is now co-located with the data?
No, so in this case, normally, the question was about where the checksum of that embedded data is. So, normally the block pointer has a checksum. That checksum is the data that's pointed to. So in this case, because we're putting the data in the block pointer itself, that block pointer, along with all the other data in that indirect block, is checksummed by the block pointer that points to it. So it's kind of the same question of like who checks the checksum. So even if you aren't doing embedded data, it's like, okay, well, I have this checksum in this indirect block. How do I know that the checksum is right? And it's right because the block pointer that points to it has the correct checksum. So basically, this whole tree forms what's called a Merkle tree, where the topmost checksum verifies that everything below it is correct.
The compressed arc feature is only about memory usage, right?
Yeah. So this is about, there's already a compressed L2 arc. So like if you have a cache device, the data is stored compressed on there. But we're working on storing the data compressed in memory. I think this is going to be especially useful on like big memory systems. Like if you have, half a terabyte of RAM, wouldn't it be great if you could cache like a whole terabyte of data in there? I mean, that's like a lot of data, right? Actually, we've seen a lot of use cases where even ignoring the L2 arc, like caching data in RAM can accelerate workloads like tremendously. Sometimes even though ZFS is like, there's some cases where it's not as fast as some other things, but like the ability to take advantage of huge amounts of memory, which are getting really, really cheap nowadays, more than makes up for that. Did I see another question?
Thanks. Do you know if someone is working on a VDEV migration, like RedZ2 to RedZ3?
No, I don't know anybody who's working on that. If you're interested in working on that, there's a really old blog post from my colleague Adam Leventhal. He and I talked about this idea a long time ago, but it's kind of tricky and doesn't really it doesn't work as smoothly as there's no like simple solution to just say like, oh, add a device and then take my RAID-Z take my RAID-Z stripe and then just add one more device and then be able to use that. Because the data is like, each block in RAID-Z is spread out over all the devices. So you can think of like the logical ordering of the data is like if the devices are columns, the blocks are kind of numbered like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we add another one here, we could, through some tricks, know that this is different and it's free, but then you have like all these single free sectors by themselves, which so if I have like 4 allocated sectors and then 1 free sector and then 4 allocated and then 1 free, I can't actually use those singleton sectors. So then you have to go like rearrange all your data, which gets you back to BP rewrite, which is a giant pain to implement and super slow. Sorry. Cool. I think, are we running out of time? Okay, great. Then more questions.
It's just you for the next 8 hours.
Oh, okay. Can somebody give me a glass of water? Then I'm good to go. Cool. I'm happy to answer more questions.
I've got one more. This is a little bit hazy, but I learned that I'm looking at ZIL performance at the moment, and where's the bottleneck with ZIL? I mean, because I understand that Oracle have just parallelized their ZIL code, and so is this a problem? And where is the problem? And how do we get around it?
Yeah. So the one main problem that I'm aware of with the ZIL is that essentially there's only one batch of writes. It only does one batch of writes at a time. So if you have lots of different file systems, then they have, there's the ZIL is specific to each file system. So, you can still get a lot of good parallelism there. But for just a given file system, one file system, if you're doing a bunch of parallel writes, then when the first write comes in, we'll put that data into the ZIL block, and we'll start the write to disk or NVRAM or wherever the ZIL lives. Then when the second write comes in, it has to wait for that first batch of writes to complete before it and everything else that's come in during that time can be written out. So in practice, I've done a little bit of performance testing on this, and in practice, it looks like this essentially halves the performance that we could get. So because the ZIL is like essentially like a linked list of blocks, we have to wait. So once we've issued that first write, we have to wait for that to complete before any future writes can logically complete. But we could theoretically start that write immediately and then wait for both writes to complete. That's also on the roadmap of what we're looking at doing at Delphix. I'm not going to make any promises about when it's going to be done, but it is something that we're looking at in the short to medium term. From what I saw, it looks like this would approximately double the write latency when you have a lot of concurrent writes going on to a file system. Sorry, it will halve the write latency, doubling your performance. Yes. Cool. Other questions? Do you have a question? All right. Thanks everyone.